Okay, hey guys, welcome back to my channel. Let's wait for 2 more minutes and then we'll get started with today's agenda. Let people join in. I hope everybody is able to hear my voice and the slide is being shown as part of the YouTube screen. Can I, yeah, can I get a yes or no if my voice is audible or not? Hi Samuel, hi Sagar. I hope everybody is able to hear my voice. I'm expecting. Thank you, Sashwati, for confirming. Okay, 26 people, not bad. Let's get started quickly. My name is Satyajit Pattnaik, and I just told Sat by mistake. People here in Hong Kong call me Sat. Well, this is Satyajit Pattnaik, guys, and welcome back to my channel. In this particular session, we shall be talking about business statistics. I hope everybody knows that we usually go live every Sunday, almost every Sunday. Last few Sundays were kind of had some issues, so we usually go live. People who are dedicatedly watching my channel, they might already know that if you want something for free, it's available on my channel. If you need more, you need to take the paid services. But are the free materials or free resources or the free videos more than enough? Yes, tons and tons of people have got jobs from the free videos as well. If you want to further study more, then you can probably join our live classes. Anyways, so what I have on my channel already, I think people must be already knowing it. I have SQL, almost 7 hours of content. Power BI, almost 7 to 8 hours of content. So this is going to be statistics, and I'm not pretty sure. I'm planning to cover the entire statistics in the next 3 Sundays. Let's see how much time we take. In case it is not covered, definitely we'll take the fourth Sunday as well. Okay, so let's get started. This video is definitely going to be in this channel forever. Don't worry, you don't have to download it or anything. I'll not make it private after this session is over, so it will be public. I will be covering the agenda in couple of minutes. Don't worry about it. So let's quickly get started, guys. Okay, so the agenda is very clear. Now, before getting into the agenda, I would like to tell that what are we going to teach? Like, how important is it going to be for data analysts and data scientists? Because I believe most of the people who have joined this session, either they might be interested in the data analytics journey or in the data science journey. So, be it data analytics or data science, statistics somehow plays a very vital role. Plays a very vital role in the field of data science because all the machine learning predictive modeling algorithms are based on statistics. Now, how important is statistics for data analyst? Well, to some extent, it is important. So, definitely, I would say it is important. And that is one of the reasons why we are studying business statistics right now. Yes, recording will be available. Don't worry. So, what is the agenda? The agenda on paper looks really small. It looks very small. Descriptive statistics, probability, inferential statistics, hypothesis testing. No, these topics looks very small, but there are so many subtopics inside it, and there are so many things I don't want to add in the agenda because it will just I'm not sure how people will react. So I've kept the agenda very short, but trust me, there are a lot of things that we are going to cover. And are these videos enough? Yes, these videos are definitely enough to get started on the go. When you start applying your analysis, you start doing your predictive modeling part and all those things, you might have to refresh some of your advanced statistics topics as well. Now, statistics is, I mean, people know, right? People study bachelor's degree in statistics. People study master's degree in statistics. So definitely 8, 10 hours, 20 hours, 50 hours, these number of hours are not going to be enough, right? But we'll try to summarize a lot of things. We'll try to cover what is basics. Now I'm expecting this crowd to not know anything. If you know anything about statistics, then also you can join. If you have no idea about all these topics, then also you can join, because I usually go from scratch. Okay. And of course, at the end of the 4 sessions, probably next Sunday, we will also be releasing you some statistics interview related questions, which my team is already creating. It's going to be like 70 to 80 pages of ebook, which you can easily refer for quick guidance. Okay, let's get started, guys. So the agenda is going to be descriptive statistics. We'll be covering measure of central tendency, measure of dispersion. We will be covering probability, probability distributions, and there are hell lot of topics inside probability. Then we will be covering inferential statistics. In that, we will be covering types of sampling techniques and confidence interval, central limit theorem as well. Last but not the least, we'll be covering hypothesis testing, significance level, p value, statistical tests. Most of these topics on the go, uh, 40% is going to be theoretical, 60% is going to be practical. That means whenever I talk about a topic, let's say skewness or kurtosis, or or any kind of outliers, any kind of topics, hypothesis testing, I will also be showing you the Python part, how it is done in Python, because that is the thing which most of the courses or most of the YouTube videos lack with. They just talk about the theory. Theory to sab jante hai. How will you apply the theory to practicals, right? That's what we will be learning in this particular sessions. Sorry, my bad. Okay, so before getting into this, we'll talk about some basic things. We'll talk about some very basic things. So initial 30 minutes is going to be about some basic things, like people who are already aware of it, probably you can go for a small break, and once you are back, you will definitely catch up the pace of the different topics. Okay, let's get started. So it all starts with data, right? Statistics, data analytics, data science, ultimately it's the game of data. So data is normally of two types. I'll try to wrap up this slide as soon as possible, because these are very, very basics. Okay. Data majorly is of two types. In simple terms, it is categorical data and numerical data. Simple. What is categorical data? If you have data like gender, male, female, or location, India, Pakistan, Bangladesh, these are all your categorical data. Okay. And then the next type of data is numerical data, which is height of different students, salary of different employees, age of different employees. These are all numerical data. Now, we call the categorical data as qualitative data and the numerical data as quantitative data. What is qualitative? A variable to describe the quality of the population. Again, inside qualitative, there are two types of data, which is nominal and ordinal. Okay. Now, what is nominal? Nominal represents the qualitative information without order. That means there is no ordering in a nominal data. For example, male and female, or location, India, Pakistan, Bangladesh, Sri Lanka, all these countries. Let's say you have a column like that. Now, that is going to be a nominal data because it has no order. Ordinal data represents qualitative information with order. Now, for example, imagine this way. You are, yeah, example is already mentioned here. We have economic status, low, medium, high. Now, you can see it is in increasing order, right? So they are following some order. Students have got some marks, and based on that, they have been graded. First grade, second grade, third grade, fourth grade, fifth grade. A plus, B plus, B minus, C plus. These kind of gradings are also called as ordinal data because they are in a order. Okay, so it indicates measurement calculations which are different and can be ranked. Similarly, quantitative or numerical data is of two types. One is discrete and one is continuous. Discrete basically means it only takes counted values, not decimal values. For example, number of students in a class. Okay, that means it's a discrete number. How many students we have? 42 students. It's a discrete number. Continuous is a number of numbers within a range of values. Let's say height of different people, height of different students. This kind of data is continuous data. Why are we studying these different types of data? Because different types of data, only once you understand which type of data it is, then you can take the next steps. So let's try to connect dots in the next 2 to 3 sessions, and by the end, let's say we will be talking about a EDA use case where we will be using a lot of statistical analysis that we will be studying, and probably these kind of things where you will be able to connect those dots ki ha, this is what we had studied and this is what we are applying the logic, so it makes sense. Okay. Derived metrics. What do you mean by derived metrics? See some, just few more slides and then we will get started with statistics. Okay. Derived metrics. See, the name itself is very clear. Derive means it has been derived from someone. It has been extracted from someone. Metrics means a matrix, as in a feature, a column. For example, if I give examples, you will understand. You have age, and you have 1,000 people: 51, 42, 29, 33, 34, and so on, and so on, dot, dot, dot. What if you want to convert this into age bins? So let's say anybody with more than 40 is greater than 40. This probably is 21 to 40, 21 to 40, 21 to 40. So you have been creating bins, right? Now, this is nothing but a derived metric. That means you have you have created this particular column from your existing column. So yeah, the PDFs and all those things will be shared after this class is over, or else, if obviously you have got this link, that means you must be a part of WhatsApp groups. In WhatsApp groups also we will update. Okay, so just make sure you like and comment down in the videos, and accordingly we'll share all these materials. Okay. So this is nothing but a created column. That means this is not a part of my existing data, but manually I have created it. So it is called as a derived metric. Create a new variable from the existing variables to get insightful information from the data. Okay. Now, different techniques are there to create such data. One of the techniques is feature binning, which I just showed you. Another technique is feature encoding. What do you mean by feature encoding? Try to understand this particular keyword. Encoding and decoding. I hope everybody must be already aware of it. Now, see, ultimate goal is, once you analyze the data, your ultimate goal is to create some predictive model that will be able to do some forecasting or do some predictions, right? So ultimately your data will be fed to computer. This is a computer. Okay, very bad drawing. So ultimately your data goes into computer, right? And computers only treat numerical attributes, they do not treat categorical values. Okay. So computers do not understand categorical data, they only understand numerical data. So even if it is gender, male or female, you cannot pass this raw data to your models, to your predictive models. So what is the right way to convert this data? Either you convert male to 1 and female to 0, or let's say you have locations: India, Bangladesh, Pakistan, Sri Lanka. India becomes 1, Bangladesh becomes 2, Pakistan becomes 3, this becomes 4. Now, this is the most idiotic way of encoding your categorical data to numerical data. Okay, but this conversion from categorical to numerical is called as encoding. Okay, now again there are various types of encoding which probably we will cover in the very last class of statistics, where we will talk about exploratory data analysis. Okay, but there are multiple types, encoding types. One is label encoding, one is one hot encoding. In case you are curious about these topics, please note it down, so that after the class you can simply do a small Google search, you will get all these answers. Label encoding is one of them, one hot encoding is one of them, dummy encoding is one of them, hash encoding is one of them. So these are 4 to 5 different types of encoding. Okay, so the simple agenda is, if I want to feed the data to computers, the most accepted format is going to be, uh, when we pass the data to computers, it has to be numerical. Even if it is numerical, the most accepted format of a computer is usually binary, in the format of zeros and ones. Okay, so let's say similarly, you have a column like gender, male, female, male, female. Now you are converting into ones and zeros. So this is also called as a derived metric, because you have derived this metric. Similarly, sometimes you also derive metrics from domain knowledge. Sometimes you derive metrics from calculating from data. Now, for example, you have sales and you have expenditure. These are the two columns that you have. You can also create a column called as profit, which will be sales minus expenditure. Now, this means profit has been created from sales and expenditure. This is also a derived matrix. Okay, got it. So, a small slide on handling missing values. We will cover this in depth later on. There are different techniques to handle missing values. And feature scaling. What is feature scaling? Okay, let me try to explain from scratch. Okay, now in the field of data science and analytics, when it all depends, I mean, it is all about data, right? You get data and then you do some analysis. Once your analysis is done, you do some prediction. Okay, so if I talk about the w- steps to solve analytical problem or a data science problem, the first step is always business understanding. Make a note of it. But I don't have a slide for that. I'm really sorry. It just popped up to my mind right now. The second step is data understanding. Data understanding, okay? The third step is data collection. Collection. The fourth step is data preparation. Preparation. And the fifth step is EDA and modeling. And the last step is deployment. Okay. These 6 steps remains the same whether you are solving a data analytics problem or a data science problem. These steps are going to be same. Nobody will be able to change it. Okay, which means it all starts with business understanding. What business problem you are trying to solve. Now, if you have telecom domain knowledge, you jump into insurance, you will not be able to understand the use cases unless and until you understand the business. So in these cases, if you are jumping from one domain to other domain, it is always advisable to read some data analytics, data science related blogs related to that particular domain. Ask your manager, talk to him, go with your manager or with your colleagues for lunch and dinner and chai sutta and all those things, and try to understand what type of business they are running if you are new to the company. If you're a fresher, business understanding is basically skipped. That means you are like water. You can flow in any domain you like to. So whenever you join a company, there will be certain period of time where they will be training you. So in that training itself, we will understand what kind of business they are trying to run and what type of problems they are trying to solve. Okay. So business understanding is must if you are trying to solve a problem. After business understanding, next comes data understanding. What do you mean by data understanding? Now imagine you are joining a MNC company. Okay, just give me 1 second. 1 second, just 1 second. Yeah, yeah, yeah. Monetization is on. Okay, I was just checking that. Yeah, yeah. Getting back to the topic. Okay, so if you are working in MNCs, matlab multinational companies, big companies like British Telecom or Morgan Stanley, JP Morgan, Tata, Tata means TCS or Infosys, companies who have been running since ages. Now these kind of companies will have multiple databases. That means different teams will be handling different data. Now, once you understood the business that I want to solve these problems, your next step is data understanding. That means you have to first see which all data are going to be important for me, and then you start collecting them. Once you collect the data after step number 3, imagine you have different sets of data. Imagine again, I majorly have experience into telecom, so most of my examples are telecom related. Okay, so example, telecom. Okay, let's say you are solving the same churn analysis problem. Okay, that means which customers are leaving the company, which are not, right? Now different data sets means this could be your customer profile information, this could be your customer usage information, this could be your customers call details, this could be your customers complaint records, and similarly there will be some other data as well which you have collected as part of step number 3. Okay, next step is data preparation, where you combine all this data and do some steps like data cleaning, you know, feature encoding and all those things. So you basically prepare your data and then come up with your final structured data or polished data or clean data. Now this data is ready for analysis. Now this is where you start working on your analysis. Majorly, if I talk about most of the companies, data analyst's role is somewhere here. Modeling is not a role of data analyst in most of the companies. Okay, so you are responsible for this data collection, preparation, and EDA. Once you do the EDA, the insights usually goes into the data science team. Now if you're working in a startup company, in that probably you can also be involved in modeling. Okay, modeling is nothing but creating predictive models, predictive analytics, machine learning. Okay, after your EDA is done, what you do as a data analyst is you go to your data science team. Sir, these not sir, I mean, yeah, we call names, right? We call by names professionally. Hey, these are the insights from this particular data. Majorly people who are leaving are males, and most of these are staying in western part of India. Okay, probably from Gujarat or probably from Rajasthan. Okay, something like that. These are your insights that you will give to your data science team. Now data science team will start creating your models. Multiple models they will create, model 1, model 2. Now these models are nothing but different statistical algorithms, random forest, knife base, blah blah blah. And then finally there will be lot of steps here which I skipped here. Lot of steps, feature engineering and all those things, feature scaling, feature engineering, running multiple models, so many things, and then deployment. Deployment means your model is ready to be deployed. Okay, this is the whole cycle of a data scientist and a data analyst. Data Science and data analytics. Okay. In some companies, data scientists are also involved in all the steps. So it depends, right? It depends from company to company. Okay. Now, why I was talking about these things? Because I didn't want it directly to jump into what is feature. Erasing all those things. If you want, probably you can just pause the video, note it down, and then play live. Okay. What is feature? Like you have collected the data, right? Customer data, age, tenure, all these are your different columns. So these different columns are called as features. Okay. Different columns are simply called as features. What is feature scaling technique? Now, scaling technique, scaling means we know. That means we want to scale it down. Now, for example, there are some students who have scored like 75%, 80%, 95%, or 72%. You want to scale it to a range of 0 to 1. What can you do? Simply, simply what I can do is there are multiple ways of scaling, right? Simple way of scaling is divided it by 100. It becomes 0.75, zero point 0.8, 0.95, 0.72. Now these are also within the range of 0 to 1. You can also divide it by the maximum number. Let's say 75, 80, sorry, this is 95 and 72. What you can do is divide it by the maximum number. That means 75 by 95. Let's say it is zero point 0.8. 80 by 95. Let's say 0.84. 95 by 95, 1. 72 by 95, let's say 0.77. So this is also the scaled values. This is called as feature scaling. That means you scale it to a range of something. Could be a range of 0 to 1, could be a range of -1 to 1, it could be anything. Now let's try to understand why are we using feature scaling, and then we will get into the mathematics behind it. Okay. Once we jump into standardization, we'll have to talk about what is this, lot of things we will cover. Okay. So let's try to understand why do we do this step. Okay. Right now also there are many people whom I know, they are studying data science. If you ask them the steps while building a machine learning model, they will be able to tell the steps. But if you ask why do you need feature scaling, probably very few of them will be able to answer. Okay, try to understand this technique. Why? Let's say we have weight and height. Okay, sorry, my bad. 75, 80, 78, 92, 65, 172, 175, 175, 180, 165. Now, simple question. I'm analyzing some customers' data. Okay. Some customers' data. That means human beings. Okay. Can you tell me what is the units in weight? Is it in kgs, lbs, or anything else? Now, everybody will be able to answer. Probably try answering on the chat box. Is it in kgs? Is it in lbs? I hope you know this, right? Or is it in grams? It is definitely in kgs, right? Human beings. Most likely it is in kgs, right? Now, why are we able to tell this that it is in kgs? Because we have been trained. We have been doing these things. We have been knowing these things. It's not defined, but I'm giving you scenarios, right? That we are analyzing customers' data. So logically, it will be kg only. Now, don't say hypothetically it could be lbs, sir. It could be grams also. It is not possible, right? So logically it is kgs. Why? Because we know that it has to be kgs, because we have been trained like that. What is height? Is it in centimeters, meters, or feet, inches? It is in centimeters, right? It is the most preferable, centimeters. Now these things we know, the computers will not know. Computers don't give a shit about these units. Okay. Now computers will expect you to pass some numbers. If you pass these raw numbers, what happens is computers give more priority to height as compared to weight. Why? Because height is in 3 decimal places, it is in 100 places, and these are in tens places. So the models will be biased. They will give more preference to height, less preference to weight. Now, what is the better technique? The better technique is to do scaling. Now, what will be the, let's say we will use the same technique, divide height and weight by the highest value. So height will be 75 divided by 92. Let's try to calculate 75 divided by 92, which is around 0.81. Okay. You cannot see the calculator because I'm only sharing you the slide, but I'm doing the calculations in parallel. 80 divided by 92 is 0.86. 78 divided by 92 is 0.84. This is 1. 65 by 92 is zero point 0.7. Let me do it for the height as well. 172 divided by the highest, which is 180. 172 by 180 is 0.95. 175 by 180 is 0.97. Similarly, 0.97. This is 1. 165 by 180 is 0.91. Okay. Now try to see this thing. If you say that the data has completely changed, right? How will the models be able to perform properly? See, in the raw data, this data point was the highest. That means the fourth customer is having the highest weight. He's the most fatty person. He could be fat or he could be healthy. Let's not talk about that. But he's the person having the most height, the highest value. In the scaled value, also, this is highest. In the original data, this is lowest. In the scale data, also, this is lowest. In the original data, this is highest. Scaled also, this is highest. This is lowest. This is lowest. So the feature importance is not changing. Only the feature values are changing. And you can see both this height and weight are in a certain range. They both are in a same range. So now this is the most acceptable format. Computers will happily treat them and treat them equally, bias free. They will not be biased. Okay. Now, the technique which I showed here is a very general technique, right? Dividing it by the highest value. Similarly, in kind of predictive analytics, or uh, in basically this feature scaling steps, there are two techniques. One of them is standardization, and one of them is normalization. Normalization. Okay, standardization and normalization. Now, I will also explain you which thing to use in which scenario. The most important question interviewers ask: when to use standardization, when to use normalization. Okay. Now, the formula is very clear. Standardization formula is x minus mu by sigma. What is mu? Mu is nothing but the mean value. And what is sigma? Sigma is the standard deviation. What is standard deviation? We'll try to cover it. Okay. So the formula of standardization, let me write it down. Xi minus mu square by n root over. This is the formula of standardization. Okay. So what is standardization? What is variance? I will explain you. Okay. I have that covered in the outlier section, Raghuram. Let me cover that outlier class. Okay. Theoretically, it is very difficult to debate on this topic. uh, Practically there are different scenarios where we do different things. Okay, so I will come to that. Outliers, very good question, but I'll cover that in outliers. I have that slide. Okay, so standardization is this and normalization is this. Okay, simple. I'm rubbing everything on the screen because I have to redo it. Okay, repeating again. Standardization formula. Standardization is, I have a beautiful handwriting, so I'm not able to write. Standardization is this. Okay, xi minus mu square by n. Okay, now imagine you have a feature, let's say height 170, 180, 160, 175. What will be the standardized value? So first we have to calculate what is mean. The mean will be addition of all the values, 170 plus 180 plus 160 plus 175 divided by 4, which is 171. Okay, what will be sigma? Let's try to do that also. So xi minus mu will be 170 minus 171 minus 1, 9 minus 9 and 4. Okay, what will be xi minus mu square? Minus 1 square will be 1, 9 square is 81, minus 9 square is 81, this is 16. So let's try to calculate. This is nothing but, sorry, this is summation. Okay, summation of numerator divided by n. So I'll just add all these numbers. 1 plus 81 plus 81 plus 16 divided by 4 root over. This is 162, 172, 178, 179 by 4. 179 by 4 will be around 4, 4, 16, 19307,205. Okay, 44.75 root over. Am I correct? 179 by 4, correct. And this root over will somewhere be around 6.7. Okay, so standard deviation is 6.7. Okay, redrawing it this side again. Let's say this is my height, 170, 180, 160 and 175. So what will be this particular term? X minus mu by sigma. X minus mu is this, minus 1 by 6.7, 9 by 6.7, minus 9 by 6.7 and 4 by 6.7. Whatever the values are, minus 1 by 6.7 is 0.84, minus 0.84. Sorry, my bad. 1 divided by 6.7, 0.14, my bad. 0.14, okay? 0.14. 9 by 6.47 will be 1 point something. This will be minus 1 point something. This will be 0.6 something, okay? So these are your standardized values. Similarly, how to find the normalized values? Again, very simple. So I'm doing it on the left side, okay? X minus x mean, which is 170 minus 160 divided by max minus mean. Max minus mean is 20, which is minus 10 by 20, which will be minus 0.5. Okay, this will be my 180 minus mean, which is 160. This will be 1. Okay, 160 minus mean, this will be 0. 175 minus mean, 15 divided by 20, 15 divided by 20, whatever it is. Okay, 0.75. So these are your normalized values. Okay, now most important question is, in predictive analytics, feature scaling is one of the most important techniques. In which technique do we use standardization and which technique we use normalization? Now, what happens is, in some of the scenarios, standardization works well. In some of the scenarios, normalization works well. Finding, telling the right thing, like Nobody can tell use standardization, it will give you the best results. No, doesn't happen that way. So what happens is we perform standardization, scale it down using standardization, go ahead, create our model, and imagine our model is giving like 85% accuracy. So we again go back to the previous step, again do normalization, and again do all the steps, and again finally check the model, let's say 83%. So we finalize that standardization is a better technique. So there is no such techniques, nobody can tell you which technique is best, which is not. Okay, so you have to arbitrarily do both of them and check it out. But normally we can go for anything. Okay, both are feature scaling technique, both are equally good. Now, why I wanted to talk about these topics before getting into, yeah, trial and error. Why I wanted to talk about these topics before getting into the actual topics, because as I told you that it is very difficult to teach these things. Sometimes we are jumping into statistics, we talk about some terms, and those terms are not covered. So I thought let's try to get started with the basics only. Okay. Okay, so what is the time right now? Almost 40 minutes down the line. Good amount of people, 52 people have joined. Thank you all for joining, guys. And please like the video in case you haven't liked it. And yeah, we'll get started with the actual statistical concepts. Statistics, uh, before getting into statistics, I think it's okay. We'll cover it on the go. So statistics is concerned with the describing, interpretation, and analyzing of the data. Majorly, statistics is of two types. Blue is not a good one. We don't have white. Why we don't have white? Okay. So descriptive statistics and inferential statistics. We'll try to cover both of them so you will understand. Feature scaling definition. Can you please elaborate? Feature scaling definition. Did you did you just join right now, Manish? Feature scaling means we have to scale down the features. Let's say you have your height like this, you have to scale it down. So your final scaled values are like this. So when you scale it down, your scaled values are most accepted format by your computers. They treat these features like these scaled values like an unbiased way. Okay. Majorly it is important in your machine learning part. I just wanted to explain this technique, so I just explained it. Okay. Please go through the video, like go back 10 minutes or 15 minutes. Again, here what I have told, I think you will be able to understand. Okay. Statistics uses analytical methods which provide the math to model and predict variation. What is descriptive statistics? Descriptive statistics means what? What is the data telling you? Okay. Both are giving results between 0 to 1. No, no, no. Both are not between 0 to 1. So descriptive statistics basically means describing data. For example, a chart or graph. And inferential statistics allows you to make predictions or inferences from the data. Sir, how? Okay, let's. I'll try to explain it again. Frame your question in a better way. Where is the problem? I'll try to answer you. No, it's not m. It's mu. This one. It's mu. Mu means mean. Mean means average. If you have five numbers, 5, 10, 15, 20, what will be the addition of these four numbers? 15, 15, 30 plus 20, 50. The average of these numbers will be 12.5. So this is mu. Okay, mean. This is mu. This is sigma. Okay. So just add these four numbers and divided it by 4, you will get 171. Standard scaling is not between a particular range. Normalization is within a range of 0 to minus 1 to 1. Okay, so simple descriptive means describing. That means what the data is telling you. Okay, and inferential basically means getting inferences. Which book is best? I don't know. Descriptive statistics describe or summarize the data and provide initial finding for the data. It gives us basic understanding for the data. Descriptive statistics does not give us any conclusion about the data, but give the brief understanding about the data. Now, simply, descriptive statistics means the what part. What is the data? Okay. The why part is something else. The how part is something else. How can you use data to do something, to do some predictions? The how part is predictive. The what part is descriptive. What is data? What is the average salary of a person? What is the average salary of a female? What is the average salary of a male? From your data, getting insights from those data is basically your descriptive statistics. Two major concepts inside this is measure of central tendency and measure of dispersion. Okay, when analyzing a graphical display, you can draw conclusions. Okay, let's not get into that. So, before getting into the next topic, let's try to understand what is an outlier. Okay, a very important topic, outlier. Outlier, otherwise called as anomalies. Okay, many of you might be knowing it. Outlier simply means a data point which is significantly bigger or smaller than rest of the data points. Okay, let's say you are analyzing height of different students, 150, 152, 145, 160, 153, 158, 190, 85, 141. Now I will explain everything, don't worry. Inferential means getting inferences out of it. We have, like, this is just the introduction part. We have inferential statistics in depth. Okay, don't worry, बस सबर रखो. My Hindi sucks, guys. So you can see I'm analyzing multiple students. Clearly, like, at least from my point of view, if I start looking at this data, I can easily spot that this is the highest person and this is the lowest person, and this highest person is, I mean, very far away from rest of the data points. If you start plotting them, most of these data points are within the range of 141 till 160, and 190 is somewhere here, and this 85 is somewhere here. So these are called as outliers. That means those data points that are very far away from rest of the data points. Another example of outlier, let's say you're analyzing some, okay, you're analyzing data. It's clearly visible that I can see an upper trend, but there are some data points that are very far away from rest of the data points. These are called as outliers. So definition wise, a data point that is significantly greater or smaller than I have outlier Python code also. I will show you how to find the outlier using Python code. Okay, but let me finish the theoretical part. Some of you might already be knowing these topics, might be boring for you, but please have patience. We will go into the Python notebook slowly. Okay, it is useful when analyzing data to identify outliers. They may affect the calculations of descriptive statistics. Outliers can occur in any given data set and in any distribution. Okay, so majorly it's very important to deal with outliers in descriptive statistics or descriptive analytics when you are analyzing the data. So it is very important to deal with outliers. There are some strategies that we follow based on different scenarios. Let's say let's say you're analyzing a particular data. There is a column called as gender. Now 90% of them are null. What can you do? Obviously you cannot populate them randomly as male and female, right? Makes no sense. So wise decision is to remove it. Let's say instead of 90 you have 20% null values. In that case what can you do? Can you delete it? No, we have to impute null values, right? So this is how you impute your null values. Now imagine you have a numerical column, let's say age. Now in age there are some outliers. Some are A28, 29, and somebody is 91. What can you do with outliers? Sometimes what we do is in descriptive statistics, obviously outliers are very predominantly visible. Let's say using box plots or using some techniques, you can easily identify those outliers. We usually don't take any actions in descriptive statistics. The thing is that outliers affect the calculations of descriptive statistics, which means the mean value, the mode value, the these kind of descriptive statistics values will change. Now for example, same example, 28, 21, 25, 91. Now let's say you are removing this outlier. What will be the average value here? The average value will be 28 plus 21 plus 25 divided by 3, 24.6, around 25. But if you add it, plus 91 divided by 4, if you add it, the average is 41.2, so which is 41. So you can see if you are removing it, the average is 25. If you are adding it, the average is 41. So it is affecting the calculations. But shall we delete it or not? It's not required. In descriptive statistics, we do not delete it. When it comes to predictive part, yes, we have to either delete it or deal with it. There are different scenarios. Okay. So let's talk about some scenarios in predictive analytics or machine learning. This is why I told you, right? There are so many topics. When we start learning about the different dots, while learning this, we are going to use this dot as well. So if this dot is not clear to you, it will be difficult. Anyways, outliers is very important in predictive analytics because they can change the model behavior. So there are different techniques of outlier detection and removal. But do we remove outliers? It depends. There are multiple machine learning algorithms which are not prone to outliers. That means it is okay to have data with outliers. They can still understand the pattern and they can still be able to act properly. But imagine you are solving a time series problem. Now, if you are solving a time series problem, you can see an upward trend. Obviously, the forecasting will also be something like this. Now, if you have outliers, more and more outliers in time series forecasting problems, we are trying to forecast. Here, your forecast might change a lot. So, outliers removal is very important in time series problems. But you might think outliers could be genuine data. It could be because of some random spike in the data. So let's say it could be because of random spike, right? Now I understand these spikes are important, but time series, while doing forecasting, it is nearly impossible to identify the next spike. You can do the forecasting whether the trend is going to increase or less or decrease, but identifying the next anomaly is near to impossible. No algorithm will be able to predict when there will be an anomaly, right? When there will be an outlier. So what we do is we usually remove these outliers. So there are some algorithmic or statistical ways of removal, and there are some traditional ways of removal as well. If you want to learn or if you want to remember some algorithmic approach, obviously one of them I will teach right now. Another technique is called as luminol. You can make a note of it. There is an algorithm called as luminol, which is by LinkedIn. I mean, LinkedIn is LinkedIn, right? We use LinkedIn. So LinkedIn's research team has created this algorithm, and they deal with outliers. They remove outliers. Okay. Let's get back to our simple techniques. Simply, how can you identify an outlier and remove them, or simply identify them? So there are some graphical ways, or there are some non-graphical ways. Some graphical ways could be histograms, box plots, and normal distribution plots. Histograms basically will tell you, histograms are something like this, right? Histograms might help you, but for me, I usually go for box plots or standardized the normal distribution techniques. What is box plot? Box plot is simply a type of visualization tool. It's a type of visualization plot, and it carries five most important information, which is minimum, maximum, Q1, Q3, and median. So when you plot a data in box plots, most likely your data points somewhere here will be termed as outliers. Okay. And either you treat them or you remove them. Okay. So it is very difficult to say which scenarios we treat them, which scenarios we delete them. It all you will gain, you will automatically know by experience. Now, what is normal distribution plot? This is where the fun begins. This is where we officially jump into the first statistical technique or first statistical topic where we will be talking about normal distribution. Yes, 5 point summary. Good one. Sagar, we in descriptive analytics or descriptive statistics, we don't remove outliers. Only when you are capturing insights for your mathematical information. In that case, as I told you, it affects calculation. So only while noting those things, you can just note it down with outliers and without outliers. These are my output. These are my calculations. But descriptive is just the what part. What is the data telling? When it comes to predictive analytics, we usually deal with outliers. Either we remove them or we keep them. There are some algorithms which are not prone to outliers. So in those kind of algorithms, we do not have the patience to remove outliers. We directly pass them. But in scenarios like time series forecasting, it is always recommended to deal with the outliers and then pass your data to the algorithms. In time series also, there are some algorithms which do not care about outliers. For example, Facebook profit or neural profit. So there are some algorithms who are okay with outliers. There are some algorithms who are not okay. So if you are using those algorithms that are not okay, in that case you have to remove outliers, else not. The next topic is normal distribution. Okay. Okay, normal distribution plots. Do I have normal distribution? As I told you, I don't have normal distribution. Must be having, yeah. It's okay. I'll cover normal distribution. See, this is the thing I don't like. From topic one, we are jumping to topic two. From topic two to topic three very quickly. Let's keep normal distribution plots on hold. I will explain you this thing, or else I'll explain. It's okay. What is normal distribution? So normally, what happens is, just give me 1 second. Let me have some water. Anybody wants to go for water break? They can go because we have already completed 1 hour. So probably let's go for water break. Even I want to drink some water, and we'll quickly be back in 5 minutes. So it should be 8 o'clock Indian time. We'll be back by 8:05. Okay, I am back, but let people be back as well. Just well, let's wait for 1 more minute, and once people are here, we'll quickly get started. Again, just confirm me because I did some changes. Just confirm if my voice is audible or not. Anybody who's still watching the stream, please confirm. Should be audio. Yeah, cool. Thank you. Okay, just last 1 minute for people who might not be back, and then we will quickly jump. Okay. So, guys, you can check out the description below as well. There are some links to all of my Telegram and WhatsApp groups. Join them if you are interested in future sessions. I We also run boot camps. So, there is a company called as Zep Analytics where we also do some boot camps related to data science, data analytics, and all those things. Anyways, that's a different topic. I usually don't force people to join my courses or anything like that. It's 2 hours. I don't know. I feel like teaching more. I was planning to make it like 1 hour, but I can still teach for 1 more hour. So let's continue. जब तक है जान. Let's continue till some time. Maybe 30 more minutes. Okay. Let's go. Okay. Let's go to the next topic, which is normal distribution. A good thing is that I kind of remember right now that I need to share my screen because I was sharing only that presentation. Okay, so we'll talk about distribution, normal distribution. Okay, normal distribution. Let me just write it down. Okay, now data can be distributed, right? Data can be distributed or spread out. Let's say your data could be something like this, something like this, or your data could be like random. Your data, the spread of data could be anything, right? It could be something like this also, right? Or it can be like this. Okay, it could be anything. There are many cases where the data tends to be around the central value with no bias left or right. So a normal scenario that we discuss is called as normal distribution. Normal distribution is something like this. That means what we expect the data should be. The data should always be like in this format. And the center location is usually called as mean, which is mu. Okay. This particular curve is called as normal distribution. Okay. It is also called as bell curve. People also call it as a bell curve. It is also called as Gaussian distribution. Okay. So, for example, if you have some columns like height of some people, or probably some blood pressure rates, or probably salary, and if you want to create histograms around it, logically we expect the data to follow the normal distribution curve. But normally, usually, our data does not follow this. It is a very rare scenario that your data will be following this normal distribution curve. Okay, but what if your data is like this? Or what if your data is like this? Or what if your data is like this? So, this is the best case scenario. But you could also end up having this, or this. So, when we have data something like this, or this, it's a good practice to convert the data into normal distribution. Simply, the definition of normal distribution is that it has to be symmetrical. The mean, median, and mode has to be symmetrical, has to be similar, and that is what is called as normal distribution. So, logically, if I keep drawing this graph, let's say like this center location is called as mu. We already know something called as standard deviation, right? Which is xi minus mu square by n summation of root over the standard deviation. We also have mu plus standard deviation, mu minus standard deviation, mu minus 2 standard deviation, mu plus 2 standard deviation, mu plus 3 standard deviation, and mu minus 3 standard deviation. Normally, 66, sorry, 65%, 65, sorry, 68%, my bad. Shit. How can I forget this number? Normally, 68% of the data fall between the this range, which is mu plus sigma till mu minus sigma. This is called as 1 sigma. 68%. Between 2 sigma, normally 95.4% falls. So mu minus 2 sigma to mu plus 2 sigma. This is called as 2 sigma. Similarly, We also have plus minus 3 standard deviation, where 99% of the data falls. Mu minus 3 sigma to mu plus 3 sigma, which is called as 3 sigma. 99.7% fall within this range of mu plus minus 3 sigma. I'm talking about the best possible scenario. If your data is following the normal distribution curve, then logically 99.7% of the data will fall under this particular range. What happens to the 0.3%, which is beyond this line? This is called as outliers. This is called as outliers. And as I told you, it's a very hypothetical scenario to have 0.3%. If you are dealing with data, let's say one of the columns, let's say salary. Imagine this particular column is not following the standard deviation as the normal distribution curve. In that case, mu plus minus 3 sigma might or might not be having 99.7% data. It could have more data, it could have less data, not exactly 99.7. So there are also chances where your outliers could be more, 0.5, 0.8%, or 1%, right? So this is a very hypothetical scenario, and none of the data really follows the normal distribution curve. If your data is not normally distributed, what we do is we kind of do some transformation techniques to convert it into normal distribution, or as much close as it can go in the normal distribution curve. Okay, that's the whole idea. Again, I have practicals for this also, but I will be covering that in the kurtosis class, which will be next to next class probably. How to deal with kurtosis, how to deal with skewness. What are the transformation that we use to make a data from non normally distributed to normally distributed. Okay, I'll cover that practically. Then comes, okay, I already explained box plots and normal distribution plot, right? So anything beyond that plus minus range is basically called as outlier. As I told you, the standard deviation technique. In statistics, if a data distribution is approximately normal, then 68% of the data lies between one standard deviation, which is called as 1 sigma of the mean. About 95.4% lies between two standard deviation, and about 99.7% lies between the three standard deviations. The standard deviation is a measure of how spread out the numbers are. Its symbol is sigma, the Greek letter sigma. Okay? Yeah, yeah. During EDA, we'll have to remove outliers. Why? Okay, there are some questions related to the ongoing topics. It is better to cover at the end, but let's see. Okay, these are minor topics. Why need descriptive for data analytics? Descriptive analytics is very important because it gives you your statistical information about the data. What is the mean, median, mode? What is the standard deviation? So, similarly, like this, is the data standardly distributed or not? These kind of things are very helpful for your next steps. So, your EDA is very important. Sorry, your descriptive analytics or descriptive statistics is very important. Log normal distribution. Yeah, I mean, log, we usually perform logarithmic transformation to convert a data from non-distribution to normally distributed. EDA full form is exploratory data analysis. There are tons and exploratory, oh shit, exploratory Data analysis. I have multiple videos on EDA. Just search on YouTube EDA, my name EDA Satyajit. You will get 2 hours videos. I think 2 to 3 videos you will get. You can go through any one of them. Your I can guarantee you all the EDA related doubts will go away. Okay. Standardization feature engineering also work of data analyst. Standardization and feature engineering. Um, not really. See, feature engineering. See, what is feature engineering? Feature engineering simply is combination of feature selection plus the engineering part, as in removal or selection of features and all those things, selecting which features to use and all those kind of things. So basic feature engineering has to be done by data analyst also, but advanced feature engineering like PCA, LDA, or any kind of other techniques, those kind of things not required for a data analyst. Is it worth to standardize the data after transformation? Is it worth to standardize the data after transformation? If I understood your question correctly, you are asking whether the data, like what is the importance of the data after performing transformation, right? If the data is normally distributed, it is very easy for descriptive analytics part and the predictive analytics part also. Exactly. For machine learning and regression, it is very useful. But see, most of the times we don't do this kind of, like, we don't uh, care about normal distribution. Why? Because as I told you, that see, in machine learning, there are multiple steps that you follow, right? Again, people who are from basic knowledge, they might be thinking that why am I jumping into machine learning? So in machine learning, there are steps, right? Let's say training, test, split, and then feature scaling, then feature engineering, model creation, hyperparameter optimization, and then doing again some hyperparameter optimization, right? So here, as all these steps are very time taking, without performing this conversion of normally distribution and all those things, we can still achieve good results. So there is no need of adding another step. So usually when it comes to machine learning, we do not care about this normal distributions and all those things. Okay, we directly feed the data. Statistics for machine learning also. Uh, I will cover the basic to intermediate level of business statistics topics. Wherever I see we need the practical implementation, I will tell you. And down the line, I also am planning to do some machine learning classes also. So in those classes, I will talk about the statistics and mathematics behind the machine learning algorithms, decision trees and random forest and all those things. Okay. Okay. So formula is very simple. It is the square root of variance. But what is variance? Variance is average of squared differences from the mean. So variance is simply this thing, xi minus mu square divided by n. The average of squared differences from the mean. This is the squared difference from the mean, divided by n is the average. So this is variance, summation. Standard deviation is root over of variance, which is root over of this thing, which will be summation of xi minus mu square divided by n. This is standard deviation. Machine learning importance in data analytics. Machine learning in depth is not required. Basics of machine learning is required for data analytics. See, I'll be very honest with you. 2 years, 3 years back, if you ask me, then I would have told machine learning is not required for data analytics. We don't have to learn all those techniques. Right now, the fight in this industry is too much. Many people are entering this industry. So I want my students to learn as much as possible so that they can excel in the interviews. I don't want them to fail as compared to other students. I'm pretty much sure other trainers might not be preparing their students for machine learning and all those things in data analytics, but I am focusing that it's better that you learn machine learning, at least the basics, right? That will keep you on top of other students, that will give you an upper edge, right? Okay, let's get back to the topic. I already have a separate video on difference between data analytics and business analytics. Just search some keywords: business analyst versus data analyst, Satyajit. Whenever you search something, just add my name. Probably you will get my videos and you can watch it. Okay, if you like my way of teaching, or else there are multiple videos which can help you as well. Okay, example: the heights at the shoulders are 600, 470, 170, 430 and 300. These are millimeters, right? 1 centimeter is 10 millimeters, right? So this is 60 centimeters, 47 centimeters, and so on. These are the five dogs that we have. Okay, 600, 470, 170, 430 and 300. Let us try to do the calculations. I will do it on parallel here. I have 600, 470. Okay, let me write it down. Height 600, 470, 170. Okay, let's not see the screen. 430 and 300. Can you tell me what will be the average of it? What will be the mean value, the mu value? Write down in the chat box. I'm sure you are able to watch my screen, but write down in the chat box 394. Now, what will be sigma? This one I will not help you. I will write down the formula for you. Summation of xi minus mu square divided by n. Try to find this. Okay. What will be xi minus mu? Xi minus mu will be 600 minus 394, which is 400. Sorry, which is 206. This one will be 76. This one will be minus 224. This one will be 36 minus 94. Okay. Now tell me the exact number of standard deviation. What is the standard deviation value? You tell me and then I will do the calculations. I'll wait 5 minutes. In the meanwhile, let me see the chat box. Tanvir is asking, is there any video related to statistics for data science? There will be no single video for statistics. You just need to know the topics, and based on those topics, you can find it in YouTube. There are so many topics in statistics that you need to learn for data science. When will be the classes conducted? My YouTube live sessions will be mostly on Sundays at 7 p.m. But what is Z score and standard deviation? Okay, good question. Z score is nothing but your standardized score. I will talk about that. After standard deviation, I will talk about it. So coming back to classes, my YouTube classes are 7 p.m. Sunday 7 p.m. But if you are interested in the bootcamp classes, which are paid, of course, we are starting a data science bootcamp from November, um, which will be starting from Children's Day, 14th of November. We haven't started marketing and all those things. Once we launch it, we have actually launched it on the website, but official launch is still pending. Once we launch it, we will post it on various WhatsApp groups also. And our courses are very affordable. Guys, waiting for standard deviation. What is the standard deviation value? Why it is taking so much of time? It is too easy. What is xi minus mu square? What is 206 square? 42436. It seems many people are not attending this class using notebooks. Guys, if you are not serious, then I will not take classes. If you give time, then I will be more than happy to help you out. And it is recommend don't watch these videos on mobile, lying on bed and all those things. If you're dead serious, open on laptops, on desktops, get your pen and paper, and then join my classes. Not a single person is able to answer. When I started asking questions, people dropped. 5 minutes back, there were 52 people. Now there are 39 people. Sir started asking questions. Let's drop. 147.32. Even I feel so. So, what will be the summation of these numbers? Let's try to do that. 8836 plus 1296 plus 50176 plus 5776 plus 42436, which is 108520. 108520 divided by what? Divided by 5, root over. Divided by 5, 21,704 root over, which is 147.3. Now, this is your standard deviation. Cool. This is your standard deviation. Now, jumping back, the mean is 394. As per my calculation is also 394. The standard deviation is 147, and it is also 147. Okay. Why it has rounded off? Just like that. Okay. We have rounded it off. Now, which means let's try to draw the standard deviation graph, the normal distribution. Let's say this is mu, which is 394. What is mu plus sigma? 394 plus 147 is 541, minus 394 minus 147 is 247, right? 1247 minus 147 is 100, minus 147 is something in minus. Okay. 541 plus 147 is 688. 688 and 835. 688 and 835. So this is your mu, mu plus sigma, mu plus 2 sigma, mu plus 3 sigma, mu minus sigma, mu minus 2 sigma, mu minus 3 sigma. Done. We already know between this 68%, between this 95, between this 99, right? So jumping back to this one, you can see this is your mean value, which is 394. This is your 541. This is your 247. Going back to the example, 600, is it between this range? No. 470, is it between this range? Yes. This one? No. This one? Yes. This one? Yes. So out of 5, Three dogs are in the range of plus minus one standard deviation, 60%. See, in five dogs, we cannot find 68%, right? I cannot find 68% in five dogs. At least I need 100 records to have a concrete number 68, right? So even in 10 dogs also it's not possible. It will either be 6 or it will be 7. So you don't start telling, sir, 6 means 60%, 7 means 70%, why it is not 68%. So in 5 dogs 68% is not possible, right? So minimum 100 dogs you should take so that you can have 68 dogs. And again, you will find 68 dogs only when the data is following the normal distribution. Okay. So you can see using standard deviation, we have a standard way of knowing what is normal and what is extra large or extra small. Rottweilers, that means this type of dog, are tall dogs, and this is called as Dachshunds. I might be wrong with my pronunciation, are a bit short. We can expect about 68% of values to be within plus minus one standard deviation. Image courtesy, mathisfun.com. Mathisfun.com is a wonderful website which you can also go through and enjoy. Even I go through a lot of blogs of Math is Fun. Okay. Yeah. One more thing. Now there is a slight change in the formula of standard deviation. Standard deviation is like this, right? Now, okay, let's try to understand terminologies. Okay. Population. Population is a term in statistics which basically means the entire population, the entire records, right? And sample means a part of it, a chunk of it. If I ask you right now, I will give you a task, go and find the average height of an Indian. People coming from different nationalities, just take an example with respect to your country. What if I tell you, try to find the average height of an Indian? Now, India has a population of 150 crores, which is the population. To find the exact average height, you need to talk to 150 crore people, which is not possible. So, in that case, what you can do is you can divide, probably you divide India into multiple segments, let's say north, west, east, and south, and try to talk to different types of people, old people, young people, different categories of people, different caste of people, different religion people, and then take kind of an average from that. Let's say you talk to 10,000 people and you found out that the average height is 171 centimeter. Now, this 10,000 is called a sample because it's not population. So, logically, in data science or in data analytics, wherever we start working with a use case or a proof of concept or any kind of data set, we always work with sample data. We always work with sample data. And when you are working on sample data, the formula of standard deviation changes to this summation. So it changes from n to n minus 1. Remember this thing, for population it is n, for sample it is n minus 1. If you think these are the 5 dogs that are alive in this entire world and you are analyzing something, in that case your standard deviation will be 147. If these five dogs are a part of a sample data, then the formula will change from 108520. Instead of divided by 5, I will do divided by 4 and then take a square root of it. So my new standard deviation becomes 164. Okay. As I already told you, there is a small change with sample data. For population, it is n. For sample, it is n minus 1. Now comes the most important question, why? Why? Why n minus 1 for sample and n for population? Again, this is one of those concepts, one of those questions where you will find tons and tons of answers on the web. Trust me, do not blindly follow those answers. Even I'm not telling you to follow my answer. Better person or the best person will be if you know any statistician, any lecturer, any PhD scholar who knows these topics. They can probably help you out with it. I mean, I can also help you out with it. Yes, there is something called as degree of freedom. I'll explain that. Why do we have n minus 1 instead of n? So I have an example, small example. Okay, the y part is basically, this part is basically called as Bessel's correction. Okay, the idea behind this is that this is a more unbiased measure of variance than the usual definition. Correct. Imagine you have a huge bookshelf. Okay, you have a bookshelf and you have certain books here. You measure the total thickness of six books to be 158 mm. There are six books, which means the mean of six samples is 26.3. Makes sense? Yes. Now you take out one and measure the first book's thickness, which is called as 1 degree of freedom. Let's say the first book is 22 mm. This means the five books that are left are having 136 mm. Five books. You measure the second book. Let's say it is 28 mm. Then becomes 136 minus 28, 108 mm for four books. And same process goes on. By the way, by the time you reach two books, let's say there are two books, and imagine two books are of 50 mm, the total thickness. By the time you measure the thickness of the fifth book individually, which is called as fifth degree of freedom, you automatically know the thickness of the remaining one. For example, you take this out and you know that this is 22 mm. So in this particular step only, I am able to understand that this is 28 mm. Quite obvious, because the total is 50, right? So while extracting the n minus 1th observation, you already know the measurements of the nth observation. So, which means that using n minus 1, you are able to get what you wanted, right? So, this is why we use n minus 1 for sample data. This is called as the n minus 1th degree of freedom. Okay. As we were in the outlier section, the various other ways of outliers detection is through box plots. I will cover this in the EDA class, probably the very last class of statistics. We will plot some box plots. I think I have a notebook also, I can open that. And there are some advanced techniques where we also we can use these techniques to detect outliers. Some of them are clustering techniques, some of them are machine learning algorithms. Okay, so one notebook I have for outliers. Let me try to open this up. So this notebook and this presentation I will not share it right now. I'll share it at the end of all the statistics classes. Notebook I will share. Okay. How many likes do we have so far on the video? Guys, 50 people are watching and 28 likes. This is not fair. Guys, like the stream, come on. Oh, why I was seeing 28 likes? Now I can see 98 likes. My bad. Okay, let's go to the topic. Okay, standard deviation. So here I'm using some NumPy and statistics library and pandas library, and I'm randomly generating some numbers. Okay, now don't ask me what is NumPy, what is pandas. If you don't know, there are 30 minutes videos on my channel. Go ahead and watch it out. Okay, NumPy statistics, NumPy and pandas, both videos are already there on my channel. If you find any topic related to data analytics or data science, just simply search that keyword with my name, probably you will get it. Machine learning videos are also coming up. So each and everything will be present on my channel. Don't worry. So I am randomly generating data. This is how my data looks like. Randomly generated data minus 16, 24, 15, blah, blah, blah. Okay. Now, okay. So here I am already using a file. Okay. I'll not use random data. I'll probably use a file. Raw sales. Let me try to open that file as well. AI data science and analytics raw sales. AI data science and analytics raw sales. This one. Download. Blindly go for Python. Once you master it, then take your next steps to learn R. Okay. But R is not mandatory. Nowadays, many companies are also focusing on Java with machine learning. So R is completely gone. In very traditional companies, they are still using R, but it's not mandatory. Even if you know Python, if it's a opening on R, they will still consider Python because Python is a superior language. Okay, so this is your data. Okay, why it is still mounting my drive? यार क्या ही हो गया? What about solidity? What is solidity? What do you mean by solidity? Hey, what happened, man? Okay, it could be a reason my drive was open, so it is failing. Yes, could be a reason. Yup. I have no freaking idea about blockchain. Oh yeah. So, okay. Raw sales. The type of data is pandas data frame. This is how my data looks like. Data sold, postcode, price, property type, blah blah blah. And I want to find the anomalies in price. Okay. Simply, if you want to, छोड़ दो. Okay. So here I've defined a function to detect outliers. Now this function is very clear. I have defined this function. I have created a blank list here. See, the code is very simple. Here I'm calling the statistics library to find the standard deviation. Okay. So this particular, I'm capturing the standard deviation, I'm capturing the mean this in this line, and then here I'm doing anomaly cutoff equals to standard deviation into 3. So I've defined a variable, let's say a, and I have defined it as 3 sigma. Okay, simple. Here what I'm doing is I'm doing lower limit equals to data mean, that means mu minus 3 sigma, upper limit equals to mu plus 3 sigma. You're getting my point, right? We are doing this thing. Anything beyond plus minus 3 standard deviation is outlier. So this is what we are doing. So for outlier in data, that means I'm going through the entire data list. If the data point is greater than this and less than this, then it is going to be appended in anomalies. This is what I'm doing simply. So data dot price, these are the data points. Okay, I'm storing this information in list one, calling this find anomalies on data of price. What is the length of my list? 461. What is the length of my data? 229,580. So how much percentage are my outliers? If I calculate 491 divided by, sorry, 461 divided by 29580, which is 1.55%. 1.55% of the data is outliers. But we all know, right? We all know that it should be zero point 0.3, right? Beyond plus minus 3 sigma should be zero point 0.3. Why it is 1.55? Because the data is not normally distributed. So there is something called as skewness. Again, this is a topic which I will be covering. I have it in the slide. The skewness score is very high. Okay, which means this data is not following the normal distribution. Okay, so let's not go into these things because I haven't covered these things, but this is how you find the anomalies using the 3 sigma rule. Similarly, you can also plot box plots also, visually they will be able to tell you what are the data points that are outliers. Okay, so that's all about this particular outlier thing. Percentile and all the general concepts behind percentile, interquartile range, I have it in the slide, so we'll probably be going through the next class. Okay, yeah, so measure of central tendency, mean median mode, and these things, measure of dispersion, we will be covering in the next class. Skewness and kurtosis will also covered in next class with the practicals, like in which scenarios to, one second, in which scenarios we have to use what, all those things we will be covering. Yeah. Okay, and what else, kurtosis will also be covered in the next class. Probability will be covered in the third class, which will be next to next Sunday. There are so many things in probability, cumulative probability. Hey, how many Sundays do we need for statistics? Just one second. 28, 15th hai, 25th hai, 18th is gone today. 25th is next class. Okay. 2nd of October, 9th of October. Yeah, we'll try to finish it in 4 classes. 9th of October. Because 16th onwards, I'm not available for again 2 3 weeks because my parents are visiting Hong Kong. So 4 classes, we will wrap it up. We have enough time. 8 hours of time is enough. We'll cover all these things. Then we also have this Z table and all those things, inferential statistics, sampling, and then we will be covering hypothesis testing. So many topics are there, we'll cover it. Okay. So that's it, guys. We'll wind up here itself. I hope you enjoyed the session. Please like, share, and subscribe the channel if you haven't. And make sure, it's a request that I hope everybody is a part of the WhatsApp group. And it is a request to, usually what happens is, I have seen there are many trainers who force people to post it on LinkedIn, and then only they will be giving access to these kind of videos and all those things. I have no such criteria of forcing you that you have to post it on LinkedIn, but as a gesture, as a support towards the channel, it's a request. Please post it on LinkedIn. Do not share it on LinkedIn, just post it individually, post it. Talk about the first class. How was the first class for you? Whether it was good, bad, whatever it is. Obviously, if it is bad, you will not post it. I hope it will be good. Tag me. It is mandatory for you all to tag me. Well, those who will be posting on LinkedIn, I don't have any special surprises, but it is just a request from my side. Post it on your wall, tag me, talk good about it, what has happened, what has not happened. And in that, you can also share the WhatsApp group links. New people can also join in, and new people can also watch in. That's a request. That's how the channel will grow. And that's all about this particular session, guys. I'll quickly take questions, probably for the last I mean, 2 more minutes, and I will take some questions. People who don't have any questions, they can quickly. No, that's all about it. Okay, let me scroll back and then start taking some questions. Uh, okay. I don't see anybody has any questions related to anything, today's topic or anything else. You can also ask. Use this as a way to talk to me also, because it's difficult for me to get in touch with you personally over calls. If you have any questions, you can ask. When there is an outlier, how feature scaling can be done efficiently? So I have already answered that. I hope that will help you out. If not, you can let me know. Feature scaling definition is covered. Why do we need descriptive analytics? As I told you, it's very information to get the mathematical information about the columns and all those things. It helps you to take your next steps. Because if you don't know mean, median, and all those things, let's say you have a column and you want to, there are so many null values. So one example of this question, what Johan Roy had asked, why we need descriptive analytics. Imagine you have a column where are so many null values, right? And you want to impute the null values. If you don't know the mean of that particular column, how will you impute it? Because one of the common techniques of imputing is mean, if it is a numerical column, right? So descriptive part is very important. During EDA, we need to remove outliers. Yes, we cannot. If you want to make your EDA lengthier, you can do it. EDA full form is already explained, exploratory data analysis. Are you gonna cover the statistics for machine learning also? Yes. Business statistics will be covered in the next 3 classes till October 9th, and then we'll take a 2 to 3 weekend break, probably 2 weekend break, 2 to 3 weekend, and then we will jump into the machine learning part. There also we will be talking about the statistics behind it, mathematics and statistics behind it. Is machine learning important for data analytics? Yes. Right now, these days, it's important. Machine learning, other word is predictive analytics. Okay, it is important. It helps you to prepare yourself in interviews. Right now, with the struggle that is happening. Many people are jumping into these industries, so it is better you learn these things. Okay. If you want to learn everything in a structured way, uh, I'm already running data analytics boot camps, which has been started like in July. Of course, 50-60% of the classes are already over. If you still want to join, Power BI is going on. You can join that program. It hardly costs you 4,000 rupees, but no compulsion. But data science program is also getting launched by data science program is getting launched by November 14th of November, Children's Day. We are launching. So those who are already my students in the data analytics part, they will be getting straight 50% off. So for them, the course fees will be just 3,000 rupees. And others who are non-students, probably it is going to be 6,000. The original price is 10,000. We are giving it for 6,000, which is going to be for 6 months. A dedicated, well structured data science program. Okay. And as I told you, like if you don't want to take courses also, if you know after what topic what needs to be studied, you simply don't need a course. But the only advantage of taking a course is it is structured, you get guidance, that's it. So you're just paying for the structure and the guidance, right? So that's it. So I usually don't force people to take my courses. Is there any video related? I think I already answered. Supriya, for this question, simply go ahead and just type in BA versus DA Satyajit. You will get a video that will help you out. Okay. Z score in standard deviation. Z score we will cover next class. So probably you will have a better understanding. Okay, okay. Questions. Will we have the access to this live session? Which are yeah, yeah, forever access. That is what I'm telling, right? Just make sure you post it on LinkedIn as well. Your friends should also know about these things, because as I'm teaching for free, so it's better that it reaches the right audience, right? Many people might be paying for these kind of classes, so it's better to just call them and join these kind of classes where they can learn for free. Sir, how can an MBA finance from Delhi University student enter the quantitative finance jobs? I mean, finance related jobs, I have no idea. But if you want to jump into finance and data science or data analytics, in that case, of course, you need to learn everything about the finance domain. On top of that, the data analytics and data science skills. Yes, you will have project based learning courses. When can we expect? We are already running data science and data analytics courses. Project based learning courses cannot be free, right? Because for projects it takes a lot of time to create a project. So if you want project related based learning courses, you can join our data science program. There will be more than 5 to 6 live projects that we will show you. It could be on deep learning, computer vision, machine learning, NLP, all these kind of topics. Is there any assessment regarding this? No assessments. Already I am spending a lot of time in teaching, so I cannot create assessments for you guys. So just better you practice yourself. ETL and data warehousing required, basics required hai. See, Power BI itself is a ETL tool, so ETL is just a concept. Okay, data warehousing and all basics is enough. ETL tool, if you ask, talent and all those things, tools are not required. See, these days, many companies are creating farce by asking ETL and all these things in interview. It's not mandatory. But yeah, basics of ETL padlo. ETL kya hai, ELT kya hai, that should be more than enough. Is Power BI or Tableau necessary for data science and machine learning? Um, for data science and machine learning, no. These are data visualization tools, BI tools, mostly used for data analytics and BI. Machine learning and data science may they don't have any role. But as I told you, no skill is not worthy. Every skill is important. So if you learn, you add those keywords to your resume. Shall I learn Python or R? Blindly go for Python, master it, and then if you have time, you can go for R programming as well. Do you teach AI as well? I teach everything, data science and analytics. I started with data science, and I really don't know how I ended up in data analytics. My channel is getting more and more contents related to data analytics, which is kind of good and bad. It is good for you all, not good for recruiters, because when I'm applying for jobs, people think that I'm into data analytics, but no, I started with data science and AI. My research is into deep learning, is into audio space, audio analytics, speech analytics, and all those things. And I have a lot of experience into deep learning. Deep learning is something which is very close to my heart. Deep learning and computer vision. Python. Manish, Python. Okay. What are the different domains? I just skipped Gargi. Your question I skipped because I have not created any assessment. So just self study on various topics. What are the different domains we can get into data science? Any? There is no such hard and fast rule for that. Any domain you can enter. Okay. Course name. Simply go to zepanalytics.com. Just go to zepanalytics.com. If you want, I can share as well. But marketing. Is it visible to you guys? हाँ. So यहाँ पे जाओगे, go to courses. See, website is going to be revamped. Right now in bootcamp, you can only see our ongoing data visualization bootcamp, but a data science bootcamp is also coming up probably in 2 days. But if you go here and search for bootcamps, this is a bootcamp that is ongoing right now. If you click on this, you can see lectures. So जिसमें the topics where you are seeing lectures, that means those are covered. Power BI 2 lectures because we have just started Power BI. So if you want to join data analytics, you can still join this program. Power BI, there are still more than 10 hours of contents to be left. Then Tableau, predictive modeling, data warehousing, ETL, everything will be taught, and it's just 4,000 rupees. And if you want to learn data science, you have to hold because this is getting launched by November. Okay. 12th of November is a typo. It is getting started from 14th of November, which is Monday. Okay. Children's Day. So that's the whole idea. Okay. Are you going to conduct live Python session? Python is done and dusted. Nobody takes interest in Python. So I already have Python videos on my channel. I tried Python, Python sessions. I would love to. I would love to take, but majority of my see, honestly speaking, my channel is not that not that big, right? That the moment I come live, thousands and thousands of people will jump in. So most of the people who are my subscribers, they are already into a phase where they have learned Python. So very few people will be interested in Python, and I don't want to, do that. So if you find me 100 students free of cost, I can do a session. You tell me, you must be having my WhatsApp number. Ping me on WhatsApp, Satyajit. I have 100 students. Please take a Python class. I will take. I will take 5 classes on Python. Any book recommended on statistics? I honestly have no idea. Uh, I can do some search on this and tell you, but right now I don't have any idea. I don't read books. I have plenty of options are available on the web. I go through multiple blogs and all those things. I go through my college books and all those things, but I don't. study the, but there are people who study, maybe I can get information. Data science bootcamp, data analytics bootcamp, anyways, is covering each and everything about data analytics. Similarly, data science bootcamp will cover each and everything about data science. On top of that, you will also get access to the data analytics course also, pre-recorded. So data analytics will be given to you as a pre-recorded content, and data science anyways will be live. So starting from Python, statistics, SQL, machine learning, natural language processing, deep learning, computer vision, just talk about a topic, I will cover that. Okay, each and every topic is covered. I don't compromise. Cost of data analytics is 4,000 rupees. It's for a 5 months program. So almost 50% is over. So you can imagine 4,000 rupees may you are getting a lot of things. And all the classes that you might have missed, you can get the recordings of it. Okay. What about live sessions for machine learning and deep learning? Deep learning, I already have a 3 hours, 3 hours computer vision lecture. I already have full convolutional neural networks is there on my channel. 3.5 hours. Machine learning, yes, I'm planning to. So I'm planning to take machine learning, but not sooner. Probably by November or December, maybe November. You have a very good teaching skills. Please continue. It's only a matter of time that learners like me, Unbin thousand. I wish, man. I would love to. Teaching is my passion. I teach. It's not for money or something. Of course, I get paid. If student takes courses, I get paid for sure. This is business for sure, but I don't treat it as a business. It's good for students and good for me as well, right? For students, they get lot of things in just 4,000, 3,000, 2,000, and I also get something. Yes, certificates will be given. So by default, you will be getting certificate auto generated from the platform. So my platform has been created in such a way, you end the course, automatically the certificate will be generated. On top of that, module based badges will also be given. Module based badges means there will be assessments and assignments and capstone projects in each module. And if you complete them and if you pass them, you will also be given special certificates which are not auto generated. Those are certificates that you will earn from us, like a certificate of excellence in Python, certificate of excellence in machine learning. So, those kind of things. But by default, certificate of completion is already there on the platform. Followed your Power BI and SQL on YouTube. Now stats as well. Very few teachers are there who cover all the topics with so much clarity. Thank you, Arsh. No placement. Oh, I'm charged 5,000, 6,000. How can I give you placements? I do have connections. And the good part is that I'm moving back to India in 2 months. So I'll build my platform. Build my connections even more. So down the line, by the time data science is over, see, 3 years back when I came to Hong Kong, I'm not boasting. I had so much connections. I was placing my students, people who know me in Bing Datum. I have placed people. There are multiple people, 15, 20 people whom I have placed in multiple companies. So, but that touch I lost when I came to Hong Kong. So I'm again moving back to India because of personal reasons. I'll be shifting to Pune. So those who are at Pune will probably meet face to face as well. So Pune, I got a job in Pune, so I'll be moving there. And I'll be in Odisha in January. January, February, I'll be in Odisha. March, I'll be moving to Pune. But the whole point is I'm moving back to India. And the reason why I'm moving back is, one of the reasons is to grow Zep Analytics. And while growing Zep Analytics, connections will also grow. And you never know, by data science end, of the program, which is March 2023, there might be placements as well. I cannot guarantee. But if you join my classes from day 1 till day last, I can guarantee you that you will get jobs. This is my guarantee. Will you be conducting any live classes in Pune? I have no idea about it. Might or might not. If Zep Analytics we take office, we are planning to. So if we take up office, probably there will be some live offline classes also. Anything can happen. We are planning. Let's see. We are planning a lot of things in Zep Analytics. In Zep Analytics, everybody might be knowing about Project Pro, right? There is a platform where they sell projects. Now, Project Pro is way costly. It is 16,000 rupees for a monthly subscription. 16,000. Of course, the level of projects are very high, but we are also creating projects. So we are also planning to launch Power BI, Tableau, machine learning projects very soon, which will be bundle projects like 20, 25 projects, and you will get it in a very low cost. So let's see. There are so many vision in mind. We are just hoping to have something fruitful in the future. That's it, guys. Stay tuned. In the next class, we'll meet and we'll go through different topics. And see you. That's all about this particular video, guys. See you in the next video. And please stay tuned. I will be updating the notebook as well. PPT, I will not share. I'm already telling you. PPT, I will share at the end of the sessions. Okay. See you guys. Bye bye.